I have this little power supply which I bought from Banggood for like $5. 12 volts, 5 amps. It's not badly made. I had a look in there. It's a switch mode power supply. It's good enough. And I also had in stock this little pulse width modulated. It's actually a little motor control which can work from 0 to 35 volts. It's also rated at 5 amps, it says. Not that I would want to stress either one of those to 5 amps, but we're going to be drawing a lot less. So the light strips over here, I've got 6 of them in a bag, and these are the little pads for them that you can stick them down with, and I'm planning to lay them out like this and make a box for them. And doing that, I've noticed that it's about 24 centimeters here would be a reasonable size, and about 19 centimeters that way. So this is kind of what I was planning. See, that's the layout, 24 by 19. I measured up the little power supply too, because I need to know how big it is. I've got to decide whether I want to put it inside the box or outside. The actual rating of the little power supply, it's 12 volts, 90 watts, 5 amps, this is for the pulse modulation, 4.5 to 35 volts. So I figured that I'm going to have 6 times. I measured the current and power that these light strips consume. They are 0.235 amps, 2.85 watts each. So we're going to be needing 1.41 amps, and it's going to be drawing about 17 watts. And this little power supply here is actually 12 volts, 5 amps. This thing is actually 60 watts, I think. The 90 watts is actually to do with the pulse width modulation module here. That's what that was. Anyway, I envisaged something like this, like a little box, a couple of toggle switches on there, and that's the rotor, the little potentiometer that's on here. And I have in my workshop some filters and some plastic sheets that came out of an LED TV, which I'm planning to cut to size and use that to distribute the light evenly, just like it does in a TV or a monitor. I'll look for some scrap wood or something that I have that I can use. So this here would be 120 volts coming in. I will put a toggle switch on the active. This is the power supply. Out we get 12 volts, goes into the pulse width modulation module, the output of which, the negative, goes to a ground. Then I'm planning to put a switch in there and divide the LED strips like 1, 3, 5, 2, 4, 6 or something like that, so I can turn down the brightness, but I can also choose not to use all the LED strips. I can only use 3 of them, let's say, in one setting and then 6 in the other, just in case I want less light or something like that for some reason. So that's what we're going to be building. And this is my little test circuit here. Now this pulse width modulation module is actually made for motors, and the waveform that I see coming out of it on the oscilloscope is a little bit odd, but it seems to be working, so it should be just fine. These light strips here, they let me see now, where's the display capture here. Bought those at AliExpress a while ago. I don't know if I paid that much for it or not, but prices seem to go up regularly. But nevertheless, for $4 for 6 light strips, they are sold as For automotive use. It says daytime running lights or something like that. I don't know. And the pulse width modulation module also I bought a while ago, and I had it in my box, so I'm using what I have. And it was 53 cents, but the shipping is $2.74, so you're really talking about what, $3.20 something cents. Let's try it out. I'll show you how it goes on the one light strip that I got hooked up here. So this also is an on-off switch, so you can switch it on. Now the camera picks this up as like it's completely lit up, and when I'm looking at my eyes I see the individual little LEDs. There's like 30 or maybe 40 of them in there or something. I haven't counted them, but that's just a guess. And then when you turn it up, you know, it gets brighter and brighter. Of course, you know, the camera is going to dull it down a bit. So in real life, it actually maybe if I hold it like that, you can see quite a distinct difference between the brightness from when it is barely on to full bore. So that's what we're going to be doing. So next I'm going to be looking in the workshop to see what scraps of wood I have to make the box out of, and then I'll cut up the, as I said, the plastic filters from the LED TV, and I'll have to run a little experiment to see the height that I have to make it, because if you're too close in distance to the strips, you'll see bands of light, and I want to have a complete opaque light source that you can't see the individual LEDs and strips and so on. So I'm gonna work that out. I think it's probably the actual TV, I think, was about, I don't know, maybe 9 centimeters, 90 millimeters deep, something like that. So I'll experiment with that and see how it works. So I'll be back when I've got the components and everything ready. Okay, so this is the schematic or circuit diagram of the what we're going to be building here. We have the power supply unit, which is a switch mode power supply. Got that from Banggood, 60 watts, 12 volts. It's made for LEDs, so that's good. These are the LED strips that we'll be using. And I've mounted the power supply already on a little piece of aluminium that I found in my junk box in the workshop. I cut some holes in it for the various components that we're going to be, switches and stuff that we're going to be mounting on there. More about that later. So we got the power supply unit. I've decided, I looked at it, I didn't see a fuse in there. It does have some protection, but you know, these Chinese things, you never know. So I decided to add this fuse unit. There's a fuse inside to the fray. Also not shown on the circuit, I'm also going to put this switch in there to switch the AC on and off. And the output of which, the power supply, I'm calling plus 12 and minus 12. It is presented to the pulse width modulation module. Now this one is actually made for motors, but it seems to be working okay with LEDs. I might replace it at some stage with a proper LED one. They have different ones for LEDs. but at the moment this is what I have in my box, and this is what I'm using. It has an output which on the little board here is called M1 and M minus. I don't know if you can see that or not. The plus V minus, M minus, and M plus. So noted that on here. Now, because in testing I found that this particular module has two characteristics. Number one, probably because it's made for motors, not for LEDs. When I turn it right down, it dims it down alright, but it's not quite as dim as I would like it to be able to go. So I'm going to add a little switch which will either select just the output from the PWM module directly, or it'll select the output through a 10 ohm 10 watt resistor. Doesn't have to be 10 watt actually, but that's what I have. This is it over here. So that's going to go through there. This is the switch we're going to be using. Now this happens to be a single pole double throw switch, but it is actually got a center off position, so in actual fact it's going to have another off position as well, which doesn't matter. It just happens, you know, as I said, I use what I have. So therefore I'm calling the output from that P plus and P minus. But because this module also, the maximum output of it is not 12 volts, it's more like 10.5 or something like that. So I decided I would like to be able to have the LED strips at full power sometimes as well. Because remember, I'm using this LightBox either for, you know, lining up things when I have negatives or something for making PCBs, but I also want to use it like for lighting up my area when I'm making videos. So it's going to do double duty, and in that case I want it to be full brightness at times. So in order to do that, I'm going to add another switch, which is going to be this one here. That is going to either switch the plus 12 and minus 12 directly and bypassing the pulse width module altogether, and or it is going to output the output from the pulse width module to the LEDs, LED plus, LED minus, they're over here. So that's the circuit that we're going to be building. Okay, I have decided not to mount this little guy yet because it's kind of cramped in there, and I want to be able to get wires into those connectors first. But we should be able to mount these little switches. Two little nuts on there, and I don't think we need both of them because we got thick aluminum there. Good guess. 8 millimeters. Yes, I think I want it to go that way. Up. Okay, it's one. Okay, where's the little notch on the side there? Okay. All right. It's probably also 8 millimeters. No, it's not. It is smaller. 7. No, 7 is too small. Oh, it is 8. I just couldn't see. All right. Okay. That's good. Now, found a little power cord in my box of goodies, and found this little strainer leaf. I harvested out of something, can't remember what. And this is going to go in here, like that, and squeeze that together with some pliers. This is always kind of tricky. There we go. And we want this to come out. Let me see now. How is that going to be mounted on this box? Oh, this is the top here. So we would like it. Go like that. There we go. Strain relief. Okay, so gotta get some wire and some solder. So on American Power Systems, okay, so on American plugs, there is a black wire that is line, which in other countries is called active, and white return, which in other countries is called neutral. So, okay, change of plan. We're going to feed this into the fuse first. It's not any closer, but it's probably more correct to do that anyway. I think I should have added a little bit of flux to that. I'm not entirely happy with the way that is. Soldering up. I think that is good. The wire got hot enough for that little bit of heat shrink tubing to shrink a little bit on the end there. So let's stretch it out again, like that. We want to put heat shrink tubing on there because this is the active line that can zap you, and we don't want to be zapped. I think I really like this fuse holder design because I'll have to wrap some tape around there. I don't want that exposed either. Anyway, now let's have a look what we've got in the way of wire. Let's continue with a piece of black wire here. And this one is going to have to go from here to the switch. That should be long enough. Right. Let's make a little hook on there, make it easier to solder. Just bend it out for the time being. I'll switch, bend it back again later on. I think this time we will add some flux. Put a little bit of water on my soldering sponge. There. Okay. There we go. I think while we're up there, I might as well shrink that heat shrink tubing. Notice that we don't use cigarette lighters like the crude boys do. I mean, $8 you can buy yourself a little, or sometimes less on AliExpress. You can buy yourself a little heater for heat shrink tubing and other stuff. Okay. Okay, so while we're there, let's add a bit of electrical tape to this. As I said, I don't like that exposed metal there on that fuse holder. That will do it. Now this is going to go through the switch. See if they can go through the little hole. Probably not. But then you never know. No, I think I'm better off just to solder it. Okay, now what have we got here? I want a smaller piece of heat shrink tubing for that. I think I can see some here that is the right size. Yeah, let's use white again. What the hey? Okay, so since we're going to be soldering it to that pin directly, a little bit of flux on the wire as well as the little pin. Okay. Coat the wire with some tinder wire. Right. I think I wanted to make a little bit better contact. Yep, I think that will do it. Now, I actually want to get a different piece of wire. I think this will be better. A little bit thinner. Where's my oh, here. Few little strands went outside, but it doesn't matter. Flux. I've learned to close that flux bottle when after I use it, because one time I didn't. I knocked it over, and it was a terrible job to get a sticky mess off my desk here. Luckily that I'm working on a silicone mat which is impervious to most things, but it was still unpleasant. Okay, this takes care of the high voltage stuff up to there. So now we should be able to wire in the power supply. In order to do that, we have little screw terminals here, and I like to put these little posts on there. So for like $20 on AliExpress you can buy these little pliers, and it comes with a box of these little terminals. Very much recommended. So let's have a look. If I can do it, I would like to use these white ones, but let's have a look if that is. Let's get the pliers out. Comes with a little pouch as well. First off, let me see if I can strip the wire. Take a little bit more. I'd have to use a thicker one. Yeah, the white one doesn't go. I'll have to use a grey one. Yeah, that goes. So then what you do, you put this in these pliers here, and you go squeeze, and there it is. Because the little screw terminals are a little bit small, I want to give it an extra squeeze to make sure it doesn't. Okay. Then what we have is marked on the actual body of the power supply. It says AC, and it's got I don't know if you can actually see it in the camera here. In any case, it says line, neutral, and ground. So let's the line one, that's active, and stick that in there. There we go. Let me use the little screwdriver here. That's not going to come out anytime soon. Then the next one is going to be the neutral. There we go. Okay, that's good. And now the earth wire. Okay, it's done. Now, what we want is, according to our circuit, let's have a look. Okay, so let's make up some leads for the other power stages. We're going to need 2 of those. Butterfingers, dropped one on the floor. Okay, that's one. Okay, and a little red wire. Those, according to this here, minus volts is over here. Looks like I need to open it up a little bit more. It'll be minus, and the other one is plus. Yes, it is. I see there's actually a little adjuster over there that you can adjust the voltage with, but I think I already measured it to be correct, 12 volts. All right. This is a little electric screwdriver. It's kind of neat because it got it cheap on AliExpress, but it works. But it locks. It's got a little light there as well, so you can actually light things up. And it locks so that when you're not applying power, you can actually use it as a hand screwdriver. Okay, we can close that up now. So let's have a look at our circuit. So what we have actually wired up this thing here. We've got the fuse, and we actually got a switch which is not on here. We've connected that up, and we got plus 12 and minus 12 coming out. So we want the plus and a minus 12 to go to two different places. It's going to go to this pulse width module, but it's also going to go to a switch, which is actually this one, and it's going to go to, both of them go to here and then to there. So therefore the easiest thing to do would be to actually solder it to these pins here, and then get another piece of wire that will actually then will eventually go to that pulse width module, which is going to be sitting over here. So first of all, let's get that needs to be smaller. 1, 2. Let's give it a bit more. There we go. It's the black one, and let me see. I need to get another piece of wire. Okay. Okay. Let us solder these little wires together. I think, let me see if this will give you a little bit of better view maybe. Need more light. Okay. So we have the plus and the minus, and this one here, this will go to the this will be going to that little PWM module. Very good. One. That's two. So let's have a look. So we're working, we've brought out the plus 12 to the switch, and we put two wires there, so now one wire is going to go to the pulse width module, and the same with the minus 12 goes to the pulse width module, which is, according to the logo on there, this is negative and this is positive, and look now. Didn't work this time. Want a little bit more. No, that's better. All right. A couple more ferrules, or whatever you call these things. Oh, long plier. One. Two. These are going to go. Let me see now. This is positive here. This is negative there. Very good. Like that. Might as well put some flux on all of them. In readiness. Okay. So let's have a look now. Yes, the negative from the pulse width module will go here to the other side of the switch. Very good. Okay, so we've got that going to here, and we now got to get that organized. Let's have a look what we can do. Figured that this resistor, it could actually go right in the middle here. That wouldn't be such a bad thing. And this is a very old resistor. I've had it in my box for over 40 years. Finally it was going to get some use. Wait. We need another piece of wire to go on there. That's good. Let's put that like so. So then we have okay. Let's solder on our yellow wire. The yellow wire is the one that goes through the resistor. that thing down with some glue later on. The red wire here has to actually go to one side of this. That's the plus 12 input on that switch. Wait a minute. It's the M plus input. Yeah, that's the M plus input goes to that switch. And now we want the yellow one to go to the other side of the switch. Yeah, we already put some flux on the switch, so we should be good. And that's fresh new wire. Okay, so that's done. Now should be able to mount this little guy here. Oops. Okay. We should be able to put that little knob on there. Okay. Yeah, that's good. This is the top. All right. Now, before we put this in place, we'll do some measurements with an ohm meter to make sure that we haven't goofed up anywhere. But I believe that all we've got left to do now is to, we've got to actually put the LED, and we have to put the LEDs in the box. Mount those somehow. Put some terminals in there, and we just got 2 wires coming off here that'll go to the LEDs. So that's what we'll be doing next. But as I said, before I do that, I'm going to check the wiring, because you know how it is when you're doing woodworking. They say measure twice and cut once. Well, here you also measure twice and before you turn it on. Okay, so that's what we're going to be doing next.